I dropped it from 5 centimeters.
It's a little pain, but it's okay.
Alright, now let's say I drop it from 50 centimeters. Why are you so scared?
No,
Did I change the mass?
No, you did not.
Why are you so scared then?
No, our goal is to find acceleration due to gravity. So you're going to let this mass fall. This mass is going to be in free fall and is going to collect some distances. We know that when you let an object fall, free fall with initial velocity 0, the distance increases quadratically, velocity increases linearly, and acceleration remains constant, which is 9.8, and that's what we want to measure, whether it is 9.8 or something else. What we need tape. So let's see, about a meter long tape. You're going to feed the tape to the spark timer. So put it inside a spark timer and attach the mass. Mass doesn't matter. It could be a hammer or feather. Doesn't really matter. Every object, the heavier or lighter, fall at the same rate, touch the ground at the same time if you drop them from same height. So attach the mass over here. So you're going to collect the distance to verify whether distance increases quadratically, which is d is equal to VAT plus half a t square, and VA is 0. All right. So turn on the spark timer. All right, let it go. See whether the distance increases quadratically. So you're going to put a line on each dot to make it as visible as possible. All right, so as you see that the distance increases quadratically. The distance increases quadratically. I'm going to measure it.
No, I am going to measure it.
Sure.
Alright, so here, let me just and for the first one, I get 1.5.
1.5.
Okay, for the second one, I get 2.
No, how it is 2?
What, 1.9 centimeters?
No, 1.8.
That is not 1.8.
Look, it is 1.8. It's B2. It's.
Dad, this is 2. This is 1.9. Alright, so now we drop down here and we get 2.3.
I see 2.2, but it's okay. 2.3, sure.
And then here we have what? 2.5.
2.5.
And finally here we have 2.9.
Okay, I see 2.8, but it's fine. So 0.015, and then
0.019,
and then
0.023, 0.025, and 0.029.
Alright, now velocity is, average velocity is distance over, of course, displacement over time. So the displacement is 0.015 over 1 and the time is 1 over 60. And then 0.015 over 1 times 60 over 1. Oh, it seems like you can multiply.
Times 60 is not 0.9.
0.9, okay.
And now we have 0.019, I think, times 60 is 1.14.
1.14.
Then 0.023 times 60 is 1.38.
1.38.
0.025 times 60 is 1.5.
1.5.
And 0.029 times 60 is 1.74.
1.74. So now here's what you're going to do. You're just going to take one decimal place. So this is 9, this is 1.1, this is 1.4. And this is 1.5, that's fine, and this is 1.7. All right.
The y-axis is...
What is the x-axis? Let me tell you what is the...
The x-axis is time.
Sure. And now let me tell you what is the y...
The y-axis is average velocity over the interval.
Sure. Now let me write down the y-axis and you watch.
Now I am going to write the y-axis and you are going to watch.
The first one is 1 over 60 comma 0.9. So 1 over 60 comma 0.9 would be
right smack dab in
the middle. Okay. Done with the first one. The second one is 2 over 60 comma 1.1.
why did you write the same thing for everyone?
3 over...
See, I told you I should have written the x-axis.
Yeah, that's right. Sure.
Okay.
2 over 60, comma...
1.1.
1.1.
See, I can read off the data too. You're my lab assistant.
Sure. 3 over 60, comma 1.4.
1.4.
4 over 60, comma 1.5.
4 over 60, comma 1.5.
And then...
5 over 60, comma 1.7.
1.7.
You don't need to say the words. I think it was here.
This is 1.8. Yeah, that's right.
So
We're not going to include 0. Hold on. We're not going to include 0. Where is the ruler? Oh?
Wow.
This is the best fit line. And I am going to choose 2 points.
I am going to choose 2 points and find the slope of the line between those 2 points so that we can find the approximate slope of this best fit line.
Okay, so let's write it. M is equal to y2 minus y1 x2 minus x1.
Wait a whoop.
Oh.
Remember, the slope of a velocity time graph is acceleration. Y is v, so v2 minus v1. And x is time, so t2 minus t1.
Wait a minute. There is a name for this acceleration. Acceleration due to gravity.
G.
You have to show respect to acceleration due to gravity by making it bigger. Now I am going to choose 2 points.
Nope. I am going to do that.
Sure.
Alright.
I'll do the math. Math is important.
So here we have 1.25 over 60, comma 1. And
So 1.25 60, comma 1?
yeah,
1 or 1.5?
1.25. 1.5 is all the way over here.
Okay.
Remember. So then we have here, let's say 0.25 over 60. Since this is a little over 8.
Over 60.
This is a little over 8, and I'm going to
8.5?
I'll say 0.836.
Oh, 0.836.
Maybe that will do the job.
36. How about 8.84? Point. Okay,
I think rounding will give us a sort of inaccurate answer.
Alright, the idea is important more than to get the accurate value, but let's
So this is point number 2,
minus
remember.
0.836 divided by 1.25 over 60 minus 0.25 over 60.
Oh, and just to make this simpler, remember that
We'll write it here. Yeah.
this is just going to be, the top has been calculated to be 0.164. The bottom is 1.25 minus 0.25. This is 1 over 60. So we
multiply,
reverse that,
okay.
and we have 0.164 times 60.
How much is that?
Let's see. 9.84!
What?
9.84!
Wow, 9.84.
Look at that!
9.8. Yeah, 9.8. Okay,
Alright.
don't forget that. So acceleration due to gravity, or the slope of this velocity versus time graph, which is acceleration due to gravity, is 9.8 meter per
Second square.
second square. Alright, do not compromise with the acceleration due to gravity, because that's what keeps you to the
Right answer.
ground.
Oh, yeah.